Hello everybody, and welcome to another coding adventure. For this one, we're going to be showing off how I created these cool looking asteroids. Going into this project, I already had a pretty good idea of what I wanted to do to create my asteroids. I wanted to start with a sphere made up of triangles, take each of the points and then manipulate those points and bringing them closer and further from the center of the sphere to make a rocky terrain, and that would be the base model of my asteroid. And then add in a few craters, and I think that would be close enough to real asteroids. You might think that just randomly moving these vertices around will create a rocky texture, but we don't actually want random, because random will lead to a spiky mess like this one. Instead of using random values, we can use something called noise. Noise is a black and white texture where the black areas smoothly blend with the white areas, and it looks something like this. We can then take points on our sphere and map them to areas on our 2D texture, where black areas move things closer to the center of the sphere and white things move the points further away. Then points near each other will have similar values and will give us the rocky terrain feel that we desire. If we animate that onto a sphere, you can see the sphere slowly become an asteroid right in front of your eyes. The other great thing about noise is that it allows us to change our asteroids. We can change them to be smoother, like this one, or we can change them to be rougher, like this one, by simply tweaking the parameters. There's also a parameter called seed that determines where in our texture we're starting from. This will make it so that we can have a theoretical infinite number of asteroids, all with unique shapes. After creating rocky terrain, the next step was to create some craters. Luckily, there was already a YouTube video by Sebastian Legge teaching how to create craters in Unity. I took his mathematical formula and had to tweak it a little bit to get it working in Godot. Here's a quick snippet of me messing around with a few of the different variables to create different kinds of craters. As you can see here is a nice looking crater, and I have a few variables that I can tweak around with to show different shapes and to change up the crater a little bit. At this point, we're making pretty good progress in creating asteroids in Godot. Unfortunately, this is when I realized that I wanted to switch and start using a 3D modeling software instead. Using Godot to create asteroids would have been really cool, as it would have allowed us to create an infinite number of shapes. The problem is triangle count. You see, one of the things you have to keep in mind when you're developing these games is how many triangles exist in your scene. The more triangles you have, you get more detail, which is awesome, but also the more triangles you have, you introduce more lag into your game. For this reason, we need to be careful about how many triangles we add to our games. We definitely don't want to sacrifice quality, but if we can reduce the triangle count to give the user a better experience, we'll choose to do that. This makes moving to a 3D modeling software the clear choice, because it has tools to help us reduce the number of triangles per model, which will in return help make our game faster. Fortunately, creating an asteroid in Blender is very similar to Godot. We start out with a sphere, making sure to add enough triangles to it. Then we add a modifier to change where each of the vertices are. The part here that took me the longest was finding the button to get to the noise parameters. It's right here. Then you can see if we select just noise, we don't actually get that much to play around with. But there is something else called clouds that is another form of noise, and we get more parameters that we can play around with. One of the differences from going from Godot to Blender is that the seed parameter is not here anymore. Instead, what we have to do is change this coordinate parameter from local to global. We can see if we keep it at local and move the shape around that it stays exactly the same. But if we change the coordinates to global and move them around, we get this weird effect where we see the points move around based on the noise that we can't see. Then we'll go into the sculpting tab and add some dents to our 3D model so that we can simulate some craters. And there you go. Now we have a unique asteroid and we can create as many asteroids as we want, making them look slightly different from each other. Out of a quick export from Blender and an import into Godot, we'll see that our asteroid is now here. You'll also notice that the surface of this asteroid is very smooth, and we definitely want something a little bit more rocky. Now, we could create something more rocky by creating more triangles, but adding more triangles to our game will make more lag. So instead, we're going to use a cool concept called normal maps. Normal maps are 2D images that capture surface information. To explain this, I'm going to use a provided normal map by Godot called the noise normal map. As you can see on this texture, most of it is purple with hints of red, green, and blue. Purple shows points that are faced directly towards us, while red, green, and blue show that those points are faced away from us. By making some light calculations, we can show a more detailed surface without increasing the lag or increasing the number of triangles in our game. If we assign this normal map to a mesh, you'll see that we create additional details. These details are fake light calculations based on the normal map. But you'll see as we move to the side that it is still a flat surface. It just looks textured because of the normal map and the light calculations that we're doing. At this point, I did a quick comparison with my asteroid to asteroid images that I found online and found that it was looking pretty good. This is where I read an article talking to indie game developers telling them to pursue stylized games versus realistic ones. It justified that realistic games tend to go out of style quickly. Think about a game made 5 years ago that pursued a realistic art style, and how that game is out of style now, that there are better, more realistic games each year because the technology keeps advancing. Contrast that to, let's say, pixel art, and a game created 5 years ago will look pretty similar to a game created today. For that reason, it can be advantageous to create a stylized game because it will keep its replayability up for years to come. I decided to take the article's advice and to try and pursue some stylized approaches to my asteroids instead of the realistic one that I created. My first idea I called Painterly, and the basic idea was instead of creating a realistic texture, I wanted to try and create something like brushstrokes, but still make it look rocky. Almost as if it was hand painted in the scene. Thankfully, I found a tutorial on YouTube describing how to do just this, and I'll link that down in the description below. The basic idea was we could take our 3D model of an asteroid and create a normal map for all of the faces. The process doesn't take too long in Blender, and at the end of the day, it looks something like this. Then you take this image and take it to a software of your choice and modify it by selecting different colors and making brushstrokes of that color. This will essentially paint the surface to look that direction because it's a normal map, and make a lot of little divots into your shape that look like brushstrokes. Creating this normal map was pretty tedious for me to do, but if I wanted to pursue this style, I think I would create a tool to rapidly create these brushstrokes programmatically instead, so that way I could create these normal maps for any asteroid really quick. But for now, I want to pursue other styles, and then I'll come back and build that tool if I decide to go with this style. The next style I try to pursue I call color ramp shading or toon shading. In this style, we manipulate how our models are shaded. Typically, we'll shade a model with a smooth gradient going from a black to a white, or whatever the color of the light is. But in this stylized version, we'll instead shade in bands of color going directly from one color to another and not smoothly shade them, like this. This creates an almost comic book-like style and is found in some games like Breath of the Wild or Tears of the Kingdom, though done a little bit differently than this. After creating these two styles, I did a quick survey amongst people in the room that were with me on which style we liked better, and the consensus was to go with the color ramp style. In retrospect, I'm glad I went with this style, and I'll show you why in upcoming clips. To get this color ramp style from Blender into Godot, I had to create a brand new shader. Luckily, I'm getting pretty comfortable with shaders from our previous video about creating nebulas, and so creating this shader wasn't too much effort. Here you can see the shader working with a basic color ramp. And then with a quick YouTube search, I found out how to add some nice black outlines to the asteroids as well, which I think adds to this kind of comic book style. When I first implemented this shader, I only considered if there was only one light in the scene. I definitely want there to be multiple lights in the scene in my future game, so I had to figure out how to implement that. While implementing those lights and moving where the attenuation variable was in my shader, I accidentally created a few different styles of color ramp shaders. Personally, I like the one where attenuation is at the end because it creates almost a more realistic style, but not quite, and I just think it looks really cool. Next, I'll show how this shader interacts with multiple lights in the scene because I think it looks kind of cool. We have this directional light, which acts kind of like a sun, but it's an all-encompassing light that just points directly in one direction, and a few of these omni lights that cast light in a sphere direction based on the point. By moving the omni lights around, you can see how the light affects the shading on the asteroid. Using these color ramps, we don't just have to do something boring like going from a dark blue to a medium blue to a light blue. We can change the hue in the middle of our color ramp to get some pretty gnarly effects. For example, I like it when I put just a band of color somewhere in the middle. I think it adds almost like a street art style effect to the asteroid. Now, I don't know which I'm going to actually end up using in my game, but the point is I've got some flexibility and can do some cool stuff with colors. It also reminds me of a pixel art video that I was watching where it describes back in the day when people were creating pixel art on machines that required pixel art, you only had so many colors that you could pick from. So what artists had to do is they started making color ramps using different colors. So for example, you could get a color ramp going from a purple to an orange to a yellow to denote dark, medium, and light colors. It's cool that we can maybe use some of those same pixel art color ramps in our game by choosing the same colors for our color ramp to make maybe asteroids that feel familiar in some way using pixel art style, but would look different enough since they would be 3D instead of pixel art. Now, just to show how cool this is, we can take this asteroid, duplicate it a handful of times, rotate it random directions, and change the scaling, and now we have a basic asteroid field. I think it looks especially cool when you move an omni light through it. Picturing in my head if that omni light was instead some kind of starship emitting light from it, and seeing how the light affects the shading on the asteroids and just kind of reinforces this realistic light with color ramp shading, which I just think looks really cool. One thing I want to point out here is just by rotating and changing the size of the asteroids, it makes it look like we're using more than just one model of asteroid, at least at a glance. This is important because we did give up the ability of creating an infinite number of asteroids by moving to a 3D modeling software instead of using our procedurally generated asteroids in Godot. But my plan is to basically create around 20 of these asteroids in different shapes and sizes in Blender, and then we'll bring those into Godot, randomly select between the 20 of them, change the rotation and change the scale slightly, and put those into an asteroid field, and I think that will give us a pretty similar effect to if we had just created a unique looking asteroid for each one. But let me know your thoughts in the comments if you can definitely tell this was the same model or not. Well, that brings us to the end of this video. Thank you so much for watching, and if you're interested in seeing more videos like that, hit the subscribe button or give the video a like. Also, as I'm a pretty new YouTuber, if you have any positive feedback to give to me about the things you liked in this video or didn't like in this video, Feel free to leave a comment and I'll try to keep that in mind as I create future videos. I also want to leave off this video with some sort of time lapse, so I decided to show off some of the color ramps that I made and that some of my friends made. Some of them are pretty ugly, but we had fun mixing and matching and trying to create some cool combinations. I hope you enjoy, and thanks again for watching this video.